Hello, everyone. So today I'm going to talk about testing, which is very dear to me. And I called it what people get wrong about testing, because I've been programming for 28 years, and I created a lot of different products over the years. I created around 20 open source projects and also worked on the New York Times for 6 years, Headspace, apps like that. My tools are used by over 80,000 teams, and I would not be able to write and maintain them if I didn't have tests. I would simply not be able to, because I would be dead. It's a full-time work to maintain those projects, and it's impossible to write some of them. Things like Sourcery, which is a code generator, it's just not possible without testing. There's too many different use cases. So testing is something that have helped me achieve success in my career, but I also teach people how to optimize their efficiency. And the thing that people get wrong about testing is they think that testing is not really valuable, and I'll tell you what people normally say. But today, what I'm going to cover is why I do think it's valuable, and I'll have literally 2 slides that should convince you pretty much about it. And I'll give you practical tips how to apply testing, what to avoid, and what to do. And we have 30 minutes, so I'm going to go pretty quick. I'm going to try to be on time. So one of the big questions that I always ask myself is, why do so few applications on iOS or in Swift in general have tests? In other domains, in web development, in other languages, testing is pretty standard. Most people write tests. So why do we not write tests? Well, so the arguments I get from people is like, oh, I don't find testing valuable, it's a waste of time. Product make a decision, we need to rush, and we'll add tests later. That later never comes. And this code is simple. I don't need tests for it. I am a senior engineer. I don't make mistakes. Well, I do make a lot of mistakes. I once pushed an update to one of my indie apps that pretty much erased half of the application because I didn't have tests. So part of my job is being a consultant and doing audits for other companies, large scale and startups as well. And from all the projects that I reviewed, maybe 20% have tests. Maybe 10% actually write new tests. You know, sometimes someone wrote tests early in the product lifecycle and then never again. And so it's really rare to find good tested applications. And those excuses were very common, but in my opinion, the real issue is that people try testing, don't know how to do it, don't spend enough time learning how to do it, so they do anti-patterns. And that's the biggest issue. They write tests that are just not maintainable. But when tests are written correctly, it's really easy to answer why testing is valuable. So here's a commit I made on main branch of my open source project that is used by tens of thousands of teams, Sourcery. Teams like Airbnb, Disney, Bumble, all use this product. Now, nowhere in my right mind would I do it without tests, because I would break code for hundreds of thousands of engineers by pushing this to the upstream. And you see how many changes there are in this simple commit. There's 10,000 additions, 21,000 deletions. What I did here, I spent a week replacing SourceKit parser with Swift syntax, because it was too slow for Airbnb, which uses Sourcery for their project. And so a week after hours, I was able to completely rewrite parsing in a project like this. And it actually worked. I didn't actually get people sending me threat emails and telling me to fix their code because their product cannot launch anymore. So this is a reason why testing is really valuable. And the other slide I want to mention is, oftentimes people think testing makes sense when you have a big team. If I work in an enterprise and I have resources and people are willing to pay, then it's valuable. I would say it's the opposite. The smaller the team, the bigger the win. Because if I am on the chopping block for making sure that the application doesn't break, I don't have QA team to support me, it's my head. It's my head. So testing just has my back. So let's go quickly through how testing ideally would look like. So the best way to do testing is doing test-driven development. So we start fresh, we need to build features. Test-driven development is pretty simple. We write tests before we write the code. And this allows us to build better APIs. This is really a huge benefit of doing test-driven first. And it catches issues very early in development and just generally makes your code more testable because you have to test it first, so there's no way to make it not testable. So we start with red-green refactor. So we write a failing test, then we make it pass with the simplest code possible, we refactor it, so we make the code actually better in the implementation detail, which should not break the passing of the test. And then we repeat and add more tests. So a simple example is, let's say we want to write a greeter. So we just want to have good morning, good afternoon, good evening. So we start with a very simple test that will fail because there is nothing to actually run, so this would not even compile. Let's say you create the empty version of a class, and then that's your first test that can pass, right? Very simple. There is nothing to worry about. It's obviously not the correct implementation because it just hard-coded string, doesn't even use the date, but it passes. So the next thing we do, we want to improve the code, right? So now we try to look at the hour, and based on the hour, we do good morning or good afternoon, and we basically prepare for more scenarios. So we add more tests that will fail because we don't have good evening, we only have good afternoon. And so this drives further implementation, it covers, increases coverage. And then at the end, once we have the green phase, for all those tests, this could look like this, which isn't ideal, but it passes all the tests, it deals with our user stories, it fills the functionality. The next thing that you will do is the refactor phase. So now the thing is, we have 3 passing tests, they're green. Whatever we change in the implementation details should never break the tests. Like, that's the whole promise. Because if I have to change the tests with the implementation detail, then do I have the confidence that I actually didn't break something? So we could refactor this into an enum or a switch, and there are different ways to do it, right? So pretty simple, we have our TDD. Now, this is ideal. Most of the time, we don't actually do TDD in bigger projects. So let's look at what we should avoid. The first thing we should focus on is understanding what not to do. Once we know what not to do, then it's much easier to do the right things. So anti-patterns. And there's a couple of anti-patterns that I get annoyed with when I write my code or when I audit code bases. The first one is testing implementation detail. This is by far the most annoying thing and the thing that leads to most people abandoning testing. So tests that break with internal implementation changes. So let's say I have an implementation that uses database underneath to store some data, or it uses user defaults, or it uses file manager. None of that matters to the feature that I'm building, right? That is all implementation detail. So we want it, if we try to have that knowledge in our test, that will create fragile tests. So for example, if I'm building a cache and I write a test that creates my cache object, which is the feature I'm testing, and then rather than using the cache object's public interface, I look at the implementation detail, like look into the storage, which is, let's say this cache only works in memory, then that is not a great implementation, because maybe we started with just memory storage, but later on we decided to use SQLite or we use something else, and now we would have to update our tests. So what we want to do is we want to create behavioral tests that only focuses on a very limited public API. So by simply adding and then getting, which is the public interface, we don't really care how it's stored. Our tests will still work. So we write tests for very simple implementation, then we build a complex implementation, and we still make sure that our data cache works. Pretty simple. Another thing that's really annoying when you have to write tests is flaky tests. And this is the reason why people comment out tests. The other one was the reason people hate tests. This is, if you find commented out tests, this is usually the anti-pattern that happens. So what flaky tests do is basically you have a test that sometimes works, sometimes doesn't work. Depending on the phase of the moon, on the speed of your CI, this is usually the reason. So what's really annoying about this is that it wastes a lot of time trying to fix bugs that are not really bugs. It's just uncontrollable environment that your test runs into. So this often stems from things like not having dependency injection and using real dependencies, or having timing issues. So if you don't control your timers and you're trying to test something based on time, you're gonna have this problem. Here's an example of a flaky test. And basically what happens here is we have real network service inside our user profile manager, and this relies on an actual network org, which is freaking terrible way to write a test. Never write tests that actually hit network unless you are doing integration tests, which I still do not like. It's unpredictable, it's extremely slow, and can fail due to network issues, to being behind a VPN or whatever. You go into a coffee shop, the network blocks some URL, and your test fail, and you're now spending hours trying to fix something that isn't broken. It's broken because it's written incorrectly. So the simplest way to refactor it, use a mock, right? Create a mock, have controllable environment for your data providing, and then you can respond quickly. You don't have to hit network, and you can run it anywhere. Fast and reliable. You definitely don't want tests that will run slowly. And anything, what does slow mean in tests? I have 10,000 tests, and they run under 1 second. One test like this could run for 3 seconds. So this is extremely slow. So you want tests that are running in like tenths of a second at the most. The way you prevent flaky tests, like it basically eliminate all the network testing. It's faster. It allows you to test various scenarios, because also the other thing is when you have mocks, then you can say, oh, this failed, this succeeded, this did that, this replied with malformed data. With real network, you cannot really do it unless your network API exposes different endpoints you're going to hit, and then you're not really testing the code that your main application would run. And it also obviously improves the code structure. So another thing is fragile tests. And this is a different kind of fragile than implementation details, because the first anti-pattern was implementation detail, which is also fragility. But this fragility is slightly different. When I talk about this, this is more about over-specification in our tests. So we can write tests that are extremely specific. Let's say we have something that prints a string, right? And we want to test that this string is correct. So fragile tests will break because there's a minor change. If I decided to change the order of the string that's being displayed, even if it contains all the information that are important, my test will break. So I can write a test like the first one, which I just hard code the string, and then this is again implementation detail, because this is exactly how it's written in the code. But I can improve this test by testing the key components. So I want this formatted description to contain the name, the age of the person, and then I can tweak it. So I can have different commas, I can have different styling. And this would make my tests more robust, right? Even if I decided to do those small changes, functionally, it would still work correctly to ensure that the user gets the same information displayed. More resilient, I would say. So we also have to use mock objects and test doubles here, but the thing is not to be overly specific. So you want to balance specificity with flexibility. So those are like the main anti-patterns that you usually find. Implementation detail has different names. You could also have some people call it anal probe, which means that you're writing your test knowing the insights of the thing that you are testing, which should not be the case. Oftentimes in bigger teams, what happens is you have QA testers, people that didn't actually write the feature, they write the tests, and then they simply don't know the implementation details. So let's look at best practices for maintainable tests. So the first thing is you should treat your tests the same care as you treat your production code, because it is what gives you safety, right? So it's really important. One of the things that I always do is I use arrange, act, assert for structuring my tests. You can also call it given, when, then. It's the same idea. Arrange is simply preparing objects and input data. Act is about performing the action that you want to test. And assert is verifying the expected outcome. This makes it much easier to read tests. It separates setup from verification. And it's easier to just simply see what we are testing. Because we look at act, OK, I'm testing adding items. And this should obviously be reflected in the name of the test. But the thing here is that it just reads easier, right? I had tests that were so hard that when they failed, I would have to spend 15 minutes just reading the test body to understand what actually is breaking. And this was because there was a lot of anti-patterns there. So the other thing that you want to do is you want to test one side effect per test. Not one assertion. Could be more assertions, but one side effect. I used to say one assertion, but that's actually not pragmatic. So the idea here is that I want a very clear and single focus of what I'm testing. And I'll give you an example. I worked at the browser company. We had Arc Browser. Arc Browser has a sidebar with all the websites. Whenever you click on a website, it creates multiple different side effects. There is a thumbnail being generated for history. There is last update date being modified in the database. There's a couple other side effects that happen. And originally, because we used TCA before I promoted non-exhaustive test store, we had tests that were 200 lines of code. And they would have to test every single assertion. When a test failed, what happened? And I observed people do it. So a test failed, TCA is really good library, so they tell you what's missing. People would just go into the log, copy what's missing, and put it in the test. There's no care given into understanding if something broke. They just filled in the missing data. So you don't want that. You want to know exactly what broke. So rather than having, let's say you have 5 side effects, rather than having one test testing 5 different side effects, you want to have 5 tests. Because then, if something breaks, you know, oh, just this broke. The thumbnail generation broke. Everything else works. So then you go into your implementation and see, why could have it broken, right? So much easier to understand. You want basically going from the test failed, I read the test name, okay, this is testing this particular thing, and then I know what needs changing in the implementation, because that's the workflow, that's the ideal one. You want to test behavior, not implementation, so focus on what the code does, not how it does it. Again, implementation detail, that's a very common theme. That's the most common issue that people do, and simply because it makes it resilient to refactoring. And a behavior testing could be like this, where we basically say that we are testing the behavior we can observe from a feature. So if I have a user manager, what I can observe is that if I add a user count should increase. Very simple, right? I don't want to look at what's being stored underneath. I don't want to know that there's a database or there's a file manager or user defaults, like Christian said. That should not matter how it's implemented. And you want to isolate tests. So each test should be able to run independently. With new Xcode, you can actually make it that the tests are running in parallel and in random order. And that's the best test, if your best verification, if your tests are isolated. Because if you run them out of order, and now sometimes they are flaky, sometimes they don't pass, they're not isolated. So this makes it easy to rely on those tests. And you basically do it by having clean slide for every test. So you can use setup, tear down. It's much easier to debug. An example might be here when we have a database, and every test we set up the database and destroy the database, and then we just add specific things for what we are testing. Otherwise, if I didn't have this and I created the database once and shared it across my multiple tests, and then I enable random order, well, now suddenly there's a problem. Or if someone adds a test in between existing tests, because they're like, oh, this looks better when I read it in this order, and now suddenly some tests start failing. So you don't want inter-test dependencies. Each test should start fresh. You want to use meaningful names. I want to understand when I read the failure in logs, especially on CI, because when I'm doing it locally, I can see the code, right? So I can see arrange act assert, and okay, this is what failed. But when I'm reading logs in CI, the names are what matters, right? With new Swift testing, which we have a talk about later, it's pretty easy because you can just put a string. But if you still have to use xtest, then simply break the convention and use this underscore. I personally find this much more readable because underscore reads like a space. So I use this even though it's not Swifty. Very simple advice. And keep tests fast. The number one thing is fast feedback loop. If I'm doing TDD and my test suite runs for 5 seconds, that's already way too long. If it runs for more, oh my God, just no. It should run under 1 second. That's the thing. And then because then you're just going to run it and run it and run it again. And it just improves developer productivity. A slow test is basically network calls, long timeouts, not controllable, continuations, stuff like that. So you want to replace that with something that you have full control over. So mocks, no dependencies, stuff like that. Again, fast feedback loop, also faster CI pipeline, so you don't wait for your CI to run for 2 hours, especially because CIs are usually slower. So there are a couple of different ways you can write tests. So let's talk about those. Snapshot tests, probably most people that actually did any tests on iOS did snapshot tests because they're simplest, and it's basically a visual regression testing. So we have our UI, and we record it into an image. It could also be used for stuff like view models data. So pretty simple, basically define, you create an object, and then you snapshot it, whether that's database or views. Point 3 is the most commonly used library right now. So here's an example from a Times application I worked on. I had slides, which were just literally slides. And I could basically just snapshot them and then compare them if something changed in the application. What's really nice about this is that it visualizes it in Git diffs. So when you are doing a PR review, you actually see what changed visually without having to fetch your PR, because most engineers don't actually fetch PRs when they do code reviews. And that's the truth. So it's nice to actually see visually, oh, this actually changed the layout and it's completely off. So you can also have designers look at those. So that's pretty cool. Very early detection of unintended changes. Another family of tests you can do is UI integration tests, which you can use UXC UI tests for. This basically allows you to simulate user interactions and test multiple components. So it's kind of like an integration test. Here, I would be careful because that's going to hit real APIs. So what I usually do in my projects is I build some abstraction where I can launch the application with a custom setup. So it's not going to hit production. It's going to hit specific testing variant of my environment, and also have some test data. That's the usual thing. But what happens here is we are able to press buttons, scroll, do pretty much everything that the user is able to do. And so we test the whole application, and there is basically all the connections that we have in production are evaluated. But this is how the code looks like. So you basically access some fields by name, then you type something, then you press some buttons. It's not terrible, but this is extremely simple test. And it verifies the outcome. We basically check if there's a welcome text available at the end. This is not the best way to do it, because what happens in that case is every time we change the implementation detail, which for this kind of test is basically the UI. So if I change how the UI looks like, all the tests have to change. If strings change, all the tests have to change. Not very maintainable. So again, we're creating anti-patterns. So what we want to use is we want to create something called page object pattern. And it's very simple. It's been since 80s, I think, so popular since 80s. The idea is that we abstract the design from the functional tests of the UI. So the way it could look like is we add this layer in between how it's actually designed and what we are trying to test. There's this thin layer that encapsulates the design. So the way you do it is you go from this brittle test that will change every time UI changes to something that describes each screen. So I have like authorization screen, and I say there is a function to type in email. And now this screen encapsulates how that actually works. Where's the field, how it's called, how to type it in. And then I can have hundreds tests say type in email. And then if the field changed visually, I only change one place, this screen proper. Very easy to update. And then this is how test looks like, because you use chaining, and you have this nice connection, and now it's readable, right? So I'm testing like authorization screen. When I type in email, I type in password, I tap login, I can verify that the login succeeded. Any design changes, I simply go into screen and test it there. I have been using this for years. I still am not a huge fan of integration tests because they still can be flaky, because it actually runs everything, and unless you have full control over the environment, it's not the fastest. I still prefer unit tests myself, but this is the only way I would write integration tests or UI tests with XC UI tests. So highly recommend that. So let's talk about how can you actually start adding tests into legacy code bases. Because all that theory is nice, but you have to have an idea how to start. So we have to approach it gradually, because it's not going to happen nowhere in my history of programming and advising companies have I seen someone say, let's block development for 2 months to add test coverage to our application. Does not happen, right? So we need a gradual approach to testing, and we want to focus on high impact areas and improve as we go. So number one thing you can do, there is a bug, write a test to reproduce that bug. And you just go like that. And every time you find a bug, you make sure this bug never happens again. The simplest, easiest way to start testing. The next thing you want to do is you want to identify critical parts of your project. So things that are the most important for operation of your business, and you want to prioritize your testing efforts on that area, because that's going to give you the biggest bang for your buck, right, for the time spent. And it increases overall reliability of your code. And then you basically gradually add more tests as you go. So there are different ways to do it. You can use approval testing for existing behavior, and you can improve test coverage around those objects that you cover. Like, so let's say you write a test first around the feature, that's old implementation, and then you start refactoring. Because then you maintain the same functionality, but the code gets better. So tests basically work as a safety net for that refactoring, and you can use different patterns like extract and override if you have hard to test code. And what extract and override is, let's say you have a view controller. You're still using UIKit, a lot of projects are, and you have a view controller that's really hard to refactor to testable, but you want to start verifying some things. So you can create a subclass of it, and then override, and make sure that this actual function is getting called. Very simple technique, trivial here as an example. It's just a stepping stone, but it goes into the direction of having more testability. Another thing you can do is, let's say you have an implementation that's not supporting mocks, right? So you have a specific service. You create a protocol for that service that basically just replicates the public API that the feature is using, and then you create a mock out of it. Pretty simple, doesn't take a long time, but it allows you to create dependency injection entry point. And once you have that, then your tests are no longer flaky. You can control the environment. You can simulate different scenarios. Approval testing is basically snapshots. So I have a controller. It's implemented all the way. I'm going to make a snapshot, and then I'm going to reproduce it in Swift UI. And the design wants pixel perfect, so this way I can actually make sure it's pixel perfect. Pretty simple and useful when you have very complex things to test. And if you have something that's really important, an existing feature that you want to modernize, use different APIs, stuff like that, you want to cover all the features, like I mentioned, all the feature functionality with tests, and then start refactoring small portions of it. And the thing here is the front-facing API should not change, so your tests should not have to change. Once you wrote those tests, they should go green to green as you refactor. That's the key component of making sure that you have the confidence to do those changes. In Sourcery, I had to touch very little tests when I was doing the parsing update. I modified maybe 10 tests out of 1,000. And the reason for that is because everyone was expecting specific behavior from the tool. So if I did something else, I would get emails. I didn't want to get emails. There are a couple of tools and libraries that you should use. Highly recommend you do. Difference, which is my library, or custom dump, which is point free, allows you to get superior diffing whenever your test failures happen. So rather than seeing a wall of text, you'll see specifically what changed between the assertions. Sourcery or SwiftyMocky for generating mocks automatically. You can also use macros like SwiftyMock and Mockable. I personally don't use a lot of macros because it's annoying to build Swift syntax for my projects. And so I still use Sourcery also. I'm the author, so I'm biased. And Swift dependencies I love from Point Free for making it easy to manage your dependencies. I have a course that I teach people on developer productivity that covers testing as well as using AI, building code gen and stuff like that. If anyone's interested, it's over 8 hours of content, and it has a lot of feedback from people here. I have to, this is my indie stuff, like I no longer work full-time. If you use the iOS Conf SG, then you'll get 20% discount for anyone in the attendees. But let's talk about the conclusions. So my key takeaways for you is testing is really crucial for long-term efficiency. It just makes your life easier. When you test, focus on behaviors, especially when you do test apps. If you do libraries like Sourcery, I need to do TDD because I need to have high coverage because everyone expects all the different parts to work perfectly. When I'm doing apps, I do more behavior-driven development, and I personally think that behavior-driven development is basically TDD with all the best practices applied. So I focus on the core things that the user is expected to do. If I can cover those in tests, I don't really look at my coverage. As long as whatever user can do works, I'm fine. You want to write clear, focused, fast, and isolated tests. That's the key. You definitely want to use dependency injection. If you do not use dependency injection, start with that even before you start testing. And if you have legacy code base that you want to upgrade, you want to make sure that you do it gradually, because rewriting everything and hoping that it's going to work has never worked in my life. And so start with high impact areas, critical user flow or core business component. Let's say you have an ad component in your application and that's drive business money. You want to make sure that's tested, because if that starts breaking, people will get fired. So don't get fired. When you work on new features and you decide that you want to start testing, when you work on new features, then make sure to write tests first, because it will make your life a lot easier. It's far easier to start with tests than to modify existing code base. So new feature is always an opportunity to write better code. And refactor existing components as you go, as you need to modify it. My pragmatic approach is, if I have a code that works, we don't have any bug reports, we don't have any crashes, I don't touch it. I just don't touch it. But if I have to add feature, if I have to change something about it, then I'll write tests for it, because I am just scared that someone is going to write me an email. And make sure that you schedule, when you do code reviews, also review your tests. If you write shitty test code, then you write shitty code. Simple as that. If you want to contact me, here's my contact information. I do consulting, audits, and I speak at conferences. So if you're organizing, always happy to talk. This is my actually 67th community event. And I need to say it, I didn't sleep at all. And I still get stressed. So if you want to start speaking and you feel stressed, that's normal. The bad news is it doesn't go away. Thank you.